All right, here we go. Our second section is on kites and trapezoids. Kites and trapezoids. Okay? So, we need to figure out what a kite is. Well, a kite has a whole bunch of properties. Now, does it look like PR is perpendicular to QS? Yes, that is one of the properties of kites, that the diagonals are perpendicular to each other. Does it look like QR is congruent to QP? This is congruent to this. Yes, it does. Does it look like SP is congruent to SR? Yes. Okay. So far we've gotten all of the properties of kites correct so far. Now, a kite is a quadrilateral. Quad means what number? 4. So it's a quadrilateral four-sided figure with two sets of consecutive sides. Consecutive means one after another. Two sets of consecutive sides that are congruent. Opposite sides are not congruent. In a parallelogram, opposite sides were congruent. Here, these opposite sides are not congruent. Okay? So in a kite, two sets of consecutive sides are congruent. Opposite sides are not congruent. Diagonals are perpendicular. Does PR bisect QS? Does PR cut QS in half? No. No. To be correct, you would have to say QS bisects PR. QS cuts PR in half. So this is congruent to this, but this part isn't congruent to this part. Okay? So QS bisects PR, not PR bisects QS. Is PQR an equilateral triangle? Does it look like it's an equilateral triangle? Not especially. PQR is not an equilateral triangle. It is an isosceles triangle. So, Manuel, you got this one wrong and this one wrong. Okay? Does PSR look like an isosceles triangle? Yes, it certainly does. Because these two sides are congruent on this, so it makes it isosceles. These two sides are congruent on this, so it makes it isosceles. Okay? So, how are the diagonals of a kite related? Well, what's one thing that we just learned in the diagonals of a kite? That they are what to each other? Perpendicular. And the long diagonal bisects the short diagonal. Okay? Or one diagonal bisects the opposite diagonal. Okay? So the diagonals are perpendicular. And if they are perpendicular, how big is angle 1 in this drawing? 90 degrees. So then we have to figure out angle 2. Well, if this is 90 here, how many degrees are in a triangle? 180. So if this is 90, there's 90 left to be shared between these two. If this is 35, how big is angle 2? 55. Okay? Now, because this is 90 and this is 90 and this is isosceles, with this isosceles, this angle is congruent to this angle by the isosceles triangle theorem. So how big is angle 3? 35 degrees. Okay? So we can figure out every angle if we have enough information. And that's what you'll be doing a little later with kites, is you'll be figuring out all kinds of angles. Okay? There's some problems will have 8 angles for you to figure out. Okay? Now, the next thing is trapezoids. What is a trapezoid? Well, a trapezoid is a quadrilateral where exactly one pair of opposite sides are parallel. So you have one pair of parallel sides. Okay? Now, there's a special type of trapezoid called an isosceles trapezoid where these are congruent. So you have one pair of sides that are parallel, one pair of sides that are congruent. And they aren't going to be the same sides. Okay? They aren't going to be the same sides. So here's an isosceles trapezoid. What happens is that diagonals are congruent. The diagonals are congruent in an isosceles trapezoid. All right, so here's one of those high voltage towers that run electrical lines from the Hawaii Dam and Pier out to this part of the state. All right, so if we're told that this big angle from here to here is 138 degrees, how big is angle 2? Well, it's an isosceles trapezoid up here, okay? So if this is 138, what's this base angle down here? Because these two are parallel, so these two angles they're consecutive or same side interior angles. Same side interior angles add up to 180. So what's 180 minus 138? 42. So this angle there is 42 degrees. So that means this angle here, angle 2, is 42 degrees. And this angle up here is 138 degrees. On isosceles trapezoids, these two sides are congruent, so the base angles are congruent here. The base angles here are congruent. Okay? All right. BD equals x plus 3. This diagonal is x plus 3. AC is 3x minus 10. This one's 3x minus 10. Because it's an isosceles trapezoid, these are congruent. X plus 3 is equal to 3x minus 11. How do we solve this? What do we move first? The x, the solo x. Subtract x from each side. 3 equals 2x minus 11. Add 11. 14 equals 2x, and divide by 2. X equals 7. So if we plug that in, 3 times 7 is 21, minus 11 is 10. 7 plus 3 is 10. Each of the diagonals are 10. Now the mid-segment. The mid-segment connects the midpoints of the two sides. And it's equal to half of this plus this. Or you add these two up and divide by 2. So, to find this mid-segment right here, you take this plus this and divide by 2. 6 plus 9 and divide by 2. Well, that's 15 over 2, or 7.5. That's what happens in mid-segments. Okay? So if they want to run a fence across this property here to separate the small dogs from the large dogs, okay, they got to figure out how much fence they need. Well, this is the midpoint of this side because each side of this is 60. This is the midpoint of this side because each side of 65. So you just take 70 plus 120 and divide it by 2. Or 190 divided by 2, which is 95. That's how much fencing they'll need to go across there. Okay? All right. So you have kites and you have trapezoids.